So we are on our second part of our three variable systems. We already solved by substitution, and now we're going to solve the systems by elimination. So we're going to start by choosing two equations that will eliminate one variable. So I can already tell that these two right here, these top two, are going to eliminate an x, okay? So I'm going to start by doing 4x plus 3y minus 2z equals -4. And underneath that, I'll have a -4x plus 2y minus 5z equals 10. Okay, and if I combine, I have 0 x's left over. I have 5 y's and minus 7z equals 6. All right, that's as far as I can go. I can't move anything. I can combine anything else. So next, you're going to pick one equation to go with this bottom one and eliminate again. So I'm just going to pick the one right above it. I'm going to use those two. And I'm going to leave the -4x plus 2y minus 5z equals 10 alone. But I'm going to multiply this bottom one by 4. So I'm going to rewrite that equation as 4x plus 8y plus 4z equals 28. So when I do that, I don't have any x's left. I have 10y minus 1z equals 38. So very quickly, I have two variable systems, two variable equations that I can go ahead and try to eliminate another variable. So I have 5y minus 7z equals 6, and from here I have 10y minus z equals 38. Okay, just off the top of my head, just by looking at that, I already saw that 5 and 10 would be a good fit. So if I multiply this top one by -2, I can combine it with the bottom one and get rid of my y's. So I'm going to rewrite those as -10y plus 14z, what I'm doing is I'm distributing this, equals -12. Okay, and I'm going to leave the second equation alone. 10y minus z equals 38. And now I have the y's canceling out. Okay, there's 0 y's left over. I have 13 z's equals 26. Conveniently, when we divide by 13, z equals 2. Okay, so we have z equals 2. I'm going to put that 2 in here and try to find y. So 10y minus 2 equals 38. And when I add 2 over, because I'm solving a two-step equation, I have 10y equals 40, which means that y equals 4. Okay, so far my final answer, I'm going to put it up here in the top. I don't have an x yet. My y is 4. My z is 2. Okay, so now we just need to go searching for the x. So we can plug y and z in for any of the equations. I'm going to go ahead and use that top equation. X plus 2y, but instead of y, I'm going to put in the 4, plus z, which is 2, equals 7. So I have x plus 10, because this is 8. X plus 10 equals 7, which means if I subtract the 10 over, x equals -3. So my final solution set is -3, 4, 2. All right, so let's do another one. This one we're going to have a special solution, and what I mean by that is it's probably going to come out as something that's not necessarily going to be numbers. Sounds interesting, huh? So let's check it out. We're going to start by trying to eliminate a variable. I'm going to start by, I think I'm going to do these two, and I'm going to multiply this top one by a 2. Because then I'll have 4x plus 2y minus 6z equals negative 4. And you might start noticing something that looks kind of crazy. Okay, so when I combine them, I have 0 x's, 0 y's, 0 z's, I have 0 of everything, and when I combine 4 and negative 4, I also get 0. Woo! So I have an infinite solution. So I'm going to have to try something else. I'm going to take the first equation and leave it alone, and I'm going to multiply the second equation by a negative 3. Okay, so I'm going to leave the first one alone, 2x plus y minus 3z equals negative 2. And I'm going to multiply the second one here by a negative 3. So I'm going to multiply by a negative 3, and it has to multiply by every term. So I have negative 21x. I have negative 9y. And I have positive 3z and negative 33. Okay. So 2 minus 21 is negative 19x. 1y minus 9y is negative 8y, and my z's are gone. So that equals negative 35. So I used the top and bottom, and I got that there's infinite solutions. Then I used the first and second equation, and this is as far as I got. So now I'm going to use the second and third equation because I have to make sure I use all of them. So this one, first and third didn't help me. First and second helped me. Now I need to do second and third. Okay? So I have 7x. I have 7x plus 3y minus z equals 11. And remember, I need to do the third equation. I have negative 4x minus 2y plus 6z equals 4. And I'm going to go ahead and stick with multiplying this top equation by 6, because then I'll have a negative 6z and a positive 6z. Okay, so I'm going to distribute that to everything. And I have 42x plus 18y minus 6z equals 66. And my bottom one will stay the same. Negative 4x minus 2y plus 6z equals 4. All right, so I'm left with 38x, and I have plus 16y equals 70. Okay. All right. So because I got infinite solutions earlier on, what I'm going to have to do is, okay, so what I have left is I have two equations with two variables each, and I'm noticing that just by looking, I can multiply the top one by a 2 to cancel out the bottom one. However, everything is going to cancel out, and that's not going to help me. So in this case, when you have infinite solutions, you will need to solve for one variable and make all of the variables in terms of that same one. So what I mean is, if you take this 38x and subtract 16y on both sides, you're going to be left with 38x equals 70 minus 16y. And so then I'm going to go ahead and solve for x. So I'm going to divide everything by 38. And x is going to be 70 38ths minus 16 38y. And go ahead and reduce that. So that's going to be 35 19ths minus 8 19ths y. I'm actually going to physically put that in the x position. So 35 19ths minus 8 19ths y, comma, y is just going to be y, okay? but I need to find z that's in terms of y. So if I bring down my equation from earlier, I have 7x plus 3y minus z equals 11. So I'm going to plug in this right here in for x. So I have 7 times 35/19 minus 8/19 y plus 3y minus z equals 11. And I'm going to go ahead and start distributing. So we have 245/19, because remember this is over 1, minus 56/19 y plus 3y minus z equals 11. So we need to solve for z. So everything else needs to go to the other side. So that means I need to subtract 245/19. I need to add 56/19 y. And I need to subtract 3y and put it all on the other side. So I'm going to be left with negative z equals 11 minus 245/19 plus 56/19 y minus 3y. So let's simplify that as much as we possibly can. So I'm going to just keep the negative z for now. We'll divide that -1 out in a little while. I need to make 11 have a common denominator of 19. So my denominator is going to be 19. And 11 times 19 is 209. And I need to subtract 245/19. Then, with my y's, I'm going to leave it as a common denominator of 19. And my 3 will then have a denominator of 19, which means I need to multiply 3 times 19 to give me 57. Okay, so negative z equals negative 36/19 minus 1/19 y. And that just goes in the z spot. After I divide out this -1 from everything. All that's going to do is change my signs. So z is positive 36/19 plus 1/19 y. So I'm going to put that in my coordinate point, and then I am done. So here we go, put it up here, 36/19 plus 1/19 y.